Good afternoon, everyone. And thank you to the UKCS Organising Committee for the invitation to speak to you this afternoon. And thanks for holding on for the late Friday afternoon slot. Having been asked to talk about intermittent catheters, I'm taking this opportunity to focus on the potential for reusable catheters by posing the question, could intermittent catheter reuse be an option? Though some of you will know about the multi-cath programme and trial, this has taken a while to get off the ground, but I'm pleased to tell you today that the multi-cath trial is now open to recruitment. So it's timely to revisit the context for the trial, the preparation work involved, and details about the trial itself. So my slides will cover background to the catheter designs, and then we'll focus on reuse of catheters, and then finally on the work of the multi-cath programme. So intermittent catheterization, or IC, is defined as the passage of a catheter into the bladder via the urethra or other catheterizable channels, such as a mitrophanol, in order to drain urine where there's either chronic or acute incomplete emptying, to maintain stricture patency, or to instill intracycle medication into the bladder. In a domestic setting, when done by the patient or their sole carer, IC is usually a clean procedure. In hospital, or where done by a non-sole carer, it is a sterile method. With careful teaching, men, women and children with a range of ability levels can master the technique. And IC provides a technique which gives users freedom from the limitations and risks associated with having an indwelling catheter. IC is not a modern technique. There are records of onion stalks being used by the ancient Chinese, and Egyptians, Romans and Greeks described tubes of wood and precious metals. Of course, these were rigid tubes without curves to negotiate the male urethra. But in the 18th century, a flexible silver coil catheter was designed by Benjamin Franklin, for which he recommended using animal gut or tallow to provide a smooth surface for comfortable insertion. Although flexible, it sounds anything but a comfortable experience, being described as like a screw, intended to be both withdrawn and introduced by turning. In the mid-19th century, mass-produced catheters became available with the introduction of Charles Goodyear's vulcanized rubber. And after the World Wars, IC became more widely used by the many young men returning home with spinal cord and other severe urological injuries. It wasn't until the 1970s when the American urologist Jack Lapides showed that a clean method, known as clean intermittent self-catheterization, could be used, espousing that residual urine volume, rather than the catheterization method itself, was the main cause of urinary tract infection. And a clean technique avoided the burden of the sterile technique and heralded a move to clean reuse of catheters. In the early 1980s, a major catheter design change occurred with the introduction of catheters with a hydrophilic coating that becomes slippery when soaked in water for short periods. These catheters were for single use only. At the time, plain uncoated catheters were still available, which could be reused by individuals catheterizing themselves. However, around 2000, licensing regulations changed, and in the absence of evidence-based cleaning guidelines, all flexible intermittent catheters, even uncoated ones that could be cleaned and reused, became licensed for single use only, with the adoption of this crossed out too. And this situation remains today. Currently available catheters have developed from those first coated catheter designs, with refinements mainly to the materials from which they're used. So we have non-PVC plastic phthalate-free catheters, silicone catheters. We recently had a cornstarch one and now have one made from PVOH. Lubrication has changed, so there are integral water and saline sachets, and gel-coated catheters. Catheters have been designed for no-touch insertion, such as this one here, with a feed-through design. And there are tip variants, so soft tips, or Tiemann tips for negotiating the prostatic urethra. The EAUN guidelines to intermittent catheterization are a bit dated from 2013, but nevertheless are very comprehensive, and they're an excellent information resource regarding catheters and the technique, so I would recommend those, and I have the link here. Also, there's comprehensive information about intermittent catheters in the Continence Product Advisor website. Catheter designs have been developed to help people with the insertion procedure. For example, recently a catheter for women here with an integral handle, a catheter here with a pop-off lid to prevent drainage until the catheter is in position, and then a whole range of accessories which can be used by men and women to enable better access to the urethra. Catheters have also been developed to meet people's lifestyle needs when discreetness is paramount and when toilet facilities may not be optimal or available at all. So, for example, very discreet catheters, here for women, but also now for men too, catheters which can be folded for storage, and catheters with an integral drainage bag here. What about options for reusable catheters? So there are many people worldwide who reuse catheters. They either have to or some prefer to, including people in low-income countries or less resourced communities where exclusive or even any use of single-use catheters is unaffordable. People who have to pay for their own catheters or prescriptions. People who don't like throwing away so many catheters. So what are their options? Well, in the UK, women have had these sets of stainless steel catheters available to them via the drug tariff for many years. That gives women the option for a lifelong product. Outside the UK, the reusable Clini catheter here is used in Australia, Japan, and South Africa, amongst other countries. Here's a female version here. But for many people, reusing their single-use intermittent catheter, or similarly reusing even a Foley catheter, is standard practice. So thinking about the question, could reusable intermittent catheters be an option? If single-use catheters are available and acceptable, why not just stick with them, you might say? Why bother thinking about what some might consider to be an old-fashioned method from which we have moved on? Firstly, as many people in the world depend on being able to reuse their catheters or make a lifestyle choice to reuse them, it would seem important to at least explore options for safe and acceptable catheter reuse. Secondly, there is a need to consider environmental concerns and sustainability around product use. This is a major issue in healthcare and not least in bladder and bowel care. A more sustainable approach to continence product provision depends on a reduction in use of single-use products or longer-lasting versions, and their substitution with reusable and recyclable alternatives. Many products used for bladder and bowel management are single-use, comprising non-biodegradable elements, including the commonly used plastic-backed single-use pads. However, where reusable versions of products exist, they can offer advantages to the user. And in fact, mixing and matching reusable and single-use products can provide users with the best of both options. And this may also be the case for intermittent catheters. The environmental impact of intermittent catheters is difficult to quantify. But in this study from Sun et al. In America, it's been estimated that annually the waste from 548 million single-use catheters is 206 million litres per annum. And this waste would all go to landfill. So catheter manufacturers are to be commended for investing in recent years in the development of biodegradable packaging, but for their catheters, they remain largely non-biodegradable. An exception to this is a new catheter manufactured from PVOH, polyvinyl alcohol, which dissolves in water after 30 to 60 minutes. Of course, any cleaning method for a reusable catheter will have its own environmental impact, and that would, of course, need to be taken into consideration. Furthermore, there are rapidly increasing costs for individuals and the NHS associated with intermittent catheters. This is prescription cost analysis data from October 2018, extrapolations from which suggest that more than 89 million catheters are used per annum. And costs to the NHS in England for intermittent catheters rose from about 20 million in 2008 to more than 100 million in 2018. The bulk of this cost would be for single-use catheters. The rise in intermittent catheter spend is likely to reflect a combination of an increase in use of the technique, but also increased unit costs for some catheter designs. It's interesting to note in that same period, the reduction in costs for indwelling catheters. As far back as 2008, the fact that only single-use catheters were widely available was being flagged, and the James Lind Alliance, which brings patients, carers and clinicians together in priority setting partnerships to identify and prioritise the top 10 unanswered questions or evidence uncertainties that they agree are the most important, made the safety of reusing catheters a top 10 priority. They challenged the use of different catheter types by posing the question, Surely single-use catheters are better for infection? Providing a definitive answer to this question led to the multi-cath programme. So the following slides will focus on the work of the multi-cath programme, in which we set out to find out more about the reuse of catheters, to provide definitive data about safety and user acceptability of using both reusable and single-use catheters. In the trial, we call this mixed use, and then ultimately to provide catheter users with informed choice about the impact of different catheter types. Multi-cath is an NIHR-funded programme led by the University of Southampton and with collaborators in Scotland and in England. Multi-cath comprises two phases. So the work in phase 1 was done in preparation for a phase 2 trial. The phase 1 work addressed the following questions. We needed to find out what users think about reuse of catheters, particularly their advantages and disadvantages. What industry and healthcare professionals think about the reuse of catheters. We needed to know more about the symptoms and experiences of users when they have an infection. And also we needed to make sure that we had a safe and acceptable method for cleaning catheters. Phase 2 is the randomized controlled trial, which addresses the question, is mixed use of multi-use and single-use catheters combined as safe as using only single-use catheters, and is it cost effective? To find out what catheter users think about single-use catheters and their perceptions of reusable catheters, given that most were only had experience of single-use catheters, we interviewed 40 catheter users. We found that both catheter types have perceived or real advantages and disadvantages. So single-use catheters were considered to lead to less infection and to give users greater freedom, particularly when away from home. But users were concerned about the level of waste and the number of catheters required that they needed to take when travelling. A reusable catheter, on the other hand, was felt to be a greener option, as fewer catheters would go to landfill. Also, there is a common concern about the risk of running out of single-use catheters, and it was felt that by having a reusable catheter, users would always have one available. However, there were concerns about hygiene and infection with reusable catheters. So although modern single-use catheters have many advantages, we've shown through these interviews that there are advantages and disadvantages to both types. In preparation for the possibility of a change in practice, there was a need to understand better the views of industry and clinicians who influence product choice. We interviewed and surveyed healthcare professionals and industry representatives. What we found was marked differences in attitudes based largely on the previous clinical experience of the healthcare professionals and the size of the company represented. So healthcare professionals with previous experience of reuse and smaller companies were more open to the potential for reuse than those with little or no experience and representatives from larger companies. There were common concerns to both industry and clinicians. They perceived an increased risk of infection. They were concerned about the increased user burden of having to clean catheters and the impact on patient choice. If at the end of the trial we find that mixed catheter use is no less safe than single-use catheterization, we will build on this work to address the barriers and facilitators to the development of newly licensed catheters and their introduction into practice. And there was consensus among these groups that if multi-use catheters were to be successfully introduced, we would need to demonstrate, of course, the ease of use, safety and effectiveness of the cleaning technique. We also needed to better understand users' experience of urinary tract infection symptoms and their subsequent actions. The existing National Institute on Disability and Rehabilitation Research, or NIDDR tool, comprises data from SCI users and could not easily be applied to the wider IC community. Our IC users reported that the terms in the NIDDR tool were not easily understood, and they offered terms which varied from those in the NIDDR tool. They also described a wide range of actions that they take when they felt they had a urinary tract infection. So a revised symptom set is being used in the trial with terms that better reflect IC users' understanding of their symptoms. This will form the basis of development of an improved, more widely usable tool later on. Finally, We needed to develop a cleaning method that would be effective at removing bacteria and also acceptable to catheter users. We identified a range of possible cleaning methods from the literature and clinical experience, including heat methods such as boiling, steam, and microwave, chemical methods including Milton and vinegar, mechanical methods including ultrasonic cleaning and soap and water. In the laboratory, catheter samples were inoculated with bacteria and cleaned at different time points, and we used tap water rinse as a control. This table shows results from the lab testing when the catheters were contaminated with E. coli and cleaned with the various methods. Bacterial count in terms of log reduction is shown on the y-axis here, and we took measurements at various time points across here. Apart from tap water in the blue diamonds here, and to a lesser extent, the ultrasonic method, which is the blue crosses here, all methods reduce the number of bacteria substantially. Vinegar was apparently effective at reducing bacterial count, but there remain non-culturable but viable bacteria. These are bacteria that appear to be dead, but in fact are not. The heat methods were discounted as they damaged the catheter surface and were also deemed to involve unnecessary risk. We were working with a panel of IC users in Bristol to check the methods for user acceptability, and heat and other methods that had to be done in a kitchen were generally felt to be unsuitable. So Milton, and to a lesser extent soap and water, were considered to be the most effective methods, which were also practical and acceptable to users. We then asked a panel of catheter users to reuse uncoated catheters, cleaning them between uses, with first soap and water, and then a combination of soap and water plus a Milton soak. Those catheters were all returned to the laboratory for analysis. In column 1, you can see the increasing number of uses here. So they started off with soap and water only, and then the Milton method, which is soap and water with Milton combined, cleaning and reusing up to 7 times, and then ultimately up to 28 plus times. In column 3, you see the number of samples that were available for analysis. And then in column 4, you see the number and proportion of samples with culturable bacteria. So you can see here that the Milton method, where we combine the Milton soak and soap and water, demonstrated a marked reduction in culturable bacteria. So the Milton method was significantly more effective than soap and water alone. Finally, we also used EDIC microscopy to examine the catheter surface for changes that could have resulted from repeated cleaning. So we used 3 different PVC catheter types. Here in this screenshot A, you can see unevenness on a catheter surface, which did not change after repeated cleaning in this screen here, B. So now I'm moving on to tell you a little bit about the trial itself. This is a non-inferiority randomized controlled trial to compare mixed catheter use. So this is using reusable and single-use catheters with control single-use catheters only. We're aiming to recruit 520 participants. We're starting with a feasibility trial in the Southampton and Glasgow areas, and then we hope to be able to move on to the main trial in Bristol, London, and Newcastle. The primary outcome is symptomatic, help-seeking, microbiologically confirmed urinary tract infection, and there's a range of secondary outcomes, including hematuria and quality of life. Follow-up is over 12 months, and it will include routine and, at the time of symptoms, urine specimens, and recording of urinary tract symptoms, catheter usage, health economics, and quality of life. The final cleaning method for the trial is soap and water, followed by a 15-minute Milton soak. This is the Milton method that I mentioned earlier. Also, we provide a syringe here so that the lumen of the catheter can be flushed through. There's a website, a multicath website, where you can see the cleaning method here. Milton is an effective, commonly used and readily available and trusted method used for babies' products, drinking water, and swimming pool disinfection. We're giving participants Optilube because the catheters that we're using don't have their own lubricant, and that has to be added. The catheters are the Clini-Silicon catheters from Create Medic. They are licensed or CE marked for reuse over 28 days when cleaned between uses with the Milton method. They have the advantage of coming with a storage tube. Here you can see this is a female version and a male version here, which can also be used for containing Milton for a cleaning method on the go. They can be folded for discrete carrying, and from preliminary user evaluation with a small group of IC users, they like the catheter design, and with practice were able to catheterize with the silicone catheter. The Multicath website provides more detail about the trial and about the background work that I've reported in brief here. You may like to listen to recordings of some of the catheter users talking about their experiences and watch the video of the cleaning video of how to clean the catheters between uses. And here is a clip from one of our early testers who have been trying reuse of catheters for the first time.
When you first asked me to reuse catheters, I thought, what a splendid idea, because it seems such a waste to throw away something like 20 catheters each week, which are just going into landfill. Also, I travel quite a bit, and my suitcase seems to be half full of boxes of catheters which I have to take. So reusable catheters, I think, have to be the way forward.
So just going back to the question that I posed at the start of the talk, could reusable intermittent catheters be an option? Well, I would say maybe, in combination with single-use ones. We have a better understanding now of the challenges of IC with both catheter types. We have an effective and acceptable cleaning method when tested with a panel. Now we need to find out in a large, well-designed trial about the safety and other key aspects of using both types. If you would like to know more about the trial, please do contact me. Finally, I would just like to finish with a plug for the Continence Product Advisor website. Many of you, I hope, will know about it, but it's recently undergone a major upgrade. This website is hosted by the International Continence Society and based on edition 6 of the ICI book Incontinence, chapter 20, and it provides evidence-based information and resources for you and your patients. Please do visit our homepage where you can listen to a short video hearing what your colleagues have to say about the website, and using a short online questionnaire, tell us what you think about it. Thank you very much to everyone for listening, and I look forward to answering your questions shortly. Thank you. Bye-bye.